everyone. So, thank you so much for coming to the Hive Think Tank event tonight. If tweeting, please, we would appreciate if you can go just with the Hive data hashtag. The Hive Think Tank is a forum for thought leadership. Through our panel discussions, fireside chats, and tech talks, we focus on two things, on all things data and on entrepreneurship. These are just few speakers that were on the Hive stage in the past. Since our inception, we organized over 150 events, and tonight's event is the 17th in this year. Our community is growing. We have over 8,000 data-driven innovators, and we'd like to thank to all of you who are here with us for the first time, and to all of you who are coming to our events on a regular basis. Upcoming event, it's scheduled for the end of June with a topic on IoT security. More on our meetup page to be announced soon. So just as you register for tonight's event, the Hive Think Tank meetup page, please just, if interested, go and register there as well. Without partners and without sponsors, many of our events wouldn't have happened, so we'd like to give a big shout out to all of them. The Hive Think Tank events are brought to you by The Hive. What The Hive is, more from Managing Director and co-founder of The Hive, PM Ravi.
Thank you, Sasha. Thank you all for coming today. So the Hive is an early stage venture studio focused on applications, use cases driven by data, largely focused on IoT, as you hear today, and we have one of our companies right behind. Check them out, Foghorn, online and enterprise segments. So those are some of the areas that we're interested in. If you have sort of ideas, want to start a company in the area, just reach out to us. Some of our companies are hiring, so Neva is basically using artificial intelligence to automate the service desk and support desk. And so they're looking for people. Sensify is in the IoT security space. Join the conversation today on Twitter. Use the hashtag HiveData. And with that, I'd like to introduce Ram Jambunathan, who is the Global VP of Corporate Strategy at SAP.
Thank you, Ravi. My name is Ram Jambunathan, as Ravi said. I'm a member of the corporate strategy team here at SAP, leading cloud and platform strategy. And within that, a number of topics we are deeply engaged with or touch. And one of the areas that we are interested in as SAP is the incubation of innovation, especially in topics which are relevant to our customers, our softwares, and the data that resides in our systems. In fact, we recently announced what we're calling right now the Emerging Business Incubator, which is focused on both incubating innovations at SAP, as well as investing in the ecosystem. I think, and this is what makes this particular discussion really relevant to us, is the fact that we have a very esteemed panel of companies that are members of the SAP ecosystem in one way or another, whether they're customer or partner or capital arm, that are also pursuing similar objectives in driving value in industrial automation, areas of robotics, automation, and so on. So with that, I'd like to invite the panel to come to the stage and ask them to then introduce themselves as they sit down. So. So, Mike, I'll ask you start, why don't you give an introduction yourself, your GE Ventures, maybe just shed a little light on what GE Ventures does.
Hi, I'm Mike Dolbec with GE Ventures. GE Ventures is a little over 3 years old, but it's part of a much larger company, which some of you are probably familiar with. We have a broad investment program. We invest a little over $100 million a year and into a variety of areas. My area that I'm responsible for is industrial software, which itself is a little broad. But we also have a healthcare practice, energy, advanced manufacturing, and some other soon-to-be announced practices, which I think you'll also find interesting. That's it.
Debjit, I'm sure next.
Yeah, hi. So I'm Debjit Mukerji. I'm director at Siemens Technology Ventures, TTB for short. We have kind of a unique mandate, unique model in the sense that we do not do equity investing. So we do have an equity investing arm, Siemens Venture Capital, and Jason's in the audience. Meet him. So Siemens Venture Capital and TTV are two corporate external innovation groups, meaning we focus systematically on startups. The way that we work is that we are looking for startups with disruptive technologies and great value propositions that intersect strategically with our businesses. So on behalf of the Siemens businesses, which are many, spanning from infrastructure of all kinds, like buildings and transportation, smart grid, also manufacturing and healthcare. We work with our internal partners, find out what's needed, how external solutions might complement what we already have, and we go out and find startups that can fill those needs. So we provide non-dilutive funding to startups. Usually, we write check sizes of a few $100,000, craft strategic collaborations that have meaningful value for both sides, and we work on those collaborations over the course of, say, 6 to 12 months. And effectively what we do is, we design these working teams. So the startup team will work with a team that we bring together from Siemens and work collaboratively on something together. So we assemble the right people within Siemens, the right decision makers, the right technical folks, and then as a result of the collaborations, we set up foundations for broader engagement from Siemens. That could be an investment, an equity investment. It could be M&A, or it could simply be a commercial relationship going forward. So TTB's been around for about 16 years. It's a pretty unique venture model for a corporate. We're based in Berkeley. We have offices in Munich and Shanghai as well. I focus primarily on energy-related topics, so smart grid, wind power, renewables, power and gas. But have also spent a lot of time looking at the IoT space, which is really a horizontal area covering many topics, including manufacturing, which we're going to talk about today.
As I mentioned, we have a mix here of corporate venture, corporate partnering, and venture capital. And
Max Wessel. I'm one of the VPs at Sapphire Ventures. Sapphire's been around for 20 years. Started out as SAP Ventures, but in 2011 we spun out and have subsequently raised $1.5 billion as an independent venture fund. We invest sort of across the spectrum, everything kind of up and down the enterprise stack, as well as some consumer products as well. Some of our notable investments are LinkedIn, Fitbit, MuleSoft, Red Hat, MySQL, etc. So a lot of name brands. Happy to talk more as we go.
And Grant, I'd love to get your perspective.
My name is Grant Allen. I'm with ABB Technology Ventures. I'm with the corporate venture arm of ABB Group. And because I often run into people in the Valley who aren't familiar with ABB, it stands for Alcia Brown Boveri. Like two of the other companies up in this panel, we've actually been around since the 1800s, believe it or not. And like two of the other companies in this panel, we are also based in Europe. So we're headquartered in Zurich over the merger of the Swiss and the Swedish company. Predominantly, we do power products, power systems, and also the automation side, robotics. We created the industrial robot back in the early 70s, Cooper followed shortly thereafter. And we do other distributed control systems, low voltage products, discrete automation motion, and other things that go into a factory. So suffice it to say, we have a lot of things out in the world. We have about 100,000 robots, and we're starting to connect all of those. So part of our job within the Ventures Group with the $100 million evergreen fund that we have is really to invest in things of strategic interest to ABB. So the deals we do have to be sponsored by business units, and we're writing checks of typically $1 to $5 million per spike. And we always syndicate. We're taking the lead about half the time. And we've been doing a lot in the robotics space. 5 of our last 7 investments have been in robotics. I'm happy to learn more on that.
Thanks. Mike, I'll start with you. So you mentioned that there's a broad space of venture investment that GE is doing today. You know, health or
Seems broad to me, yeah.
or industrial automation or advanced manufacturing. Are the theses for how you're selecting investments, do they differ by area? And specifically, when we think about advanced manufacturing or new product areas or industrial automation, say, do you look for different things, different capabilities or attributes when you're selecting investments?
I think that we use a standard, we're strategic investors, like most of us here. And we use a standard venture capital methodology to vet what are relevant opportunities, but also what are reasonably priced companies that have a chance of growing rapidly. So in some sense, if you back up far enough, it's a pretty standard mix of venture capital method and what's strategic. And the idea is that you prevent yourself from talking yourself into doing something strategic, maybe not so strategic, you fall in love with it, by also disciplining yourself to use financial metrics. Each practice has a slightly different relationship with the, let's call it the mothership, the business unit or 2 or 3, which they're in some sense investing on behalf of. So in my case, the mothership is GE Digital. In the healthcare case, it's most often GE Healthcare. And so the objectives there from time to time vary quite a bit because it depends on, okay, what are we investing in, and is this some sort of incremental improvement in the industry, or is this a disruptive thing that, in some sense, we're taking a bet that this innovation might turn into something that's very disruptive. So I guess if you get close enough, they're sufficiently different. But for me, the thing that's interesting is that increasingly, I'd say 85% of what every other practice does involves software. I was just discussing this with the group earlier. We're having to invent new ways to collaborate because the darn companies aren't organized the way we are, right? So we have to figure out, okay, which team can we put together that has the relevant experience in this market, in this technology, who's had a career perhaps in this industry, so who knows the player. So it's forced us to do that.
And like ABB, for example, do you need a business sponsor as to invest? Do you look for one, or do you make investments independent of, say, what the business requires, but looking at things from a strategic lens? Because you mentioned disruption.
Right. Well, for me personally, I don't need a sponsor. But as advice to people who are in corporate venture capital, the key is not to get too far off the reservation there. So I like to make investments that have a line of sight to a commercial relationship within, say, 24 months. In other words, it's conceivable that the company will finish what they're doing and that thing or service is commercially relevant to some part of the GP. So anything further than 2 years out, so much can happen, it's really hard to guess. But no, I don't technically need a business sponsor. I just spend a lot of time keeping a lot of relationship with the potential sponsor.
So, Sam sitting in the audience, I've heard this so far, and I'm thinking, okay, I've heard that there's opportunities for either engaging via like a business development function, like ABB has, Siemens has versus corporate venture that would be offered by GE and ABB, or traditional venture capital, let's say, like Sapphire has. So Max, you see a promising young entrepreneur in the audience. I come up to you with, make me an offer. Why should I take your money, say, over that over a corporate venture firm? Or is it a choice? Is it an and or is it an or?
Yes, this is a wonderfly difficult question to answer, given that this is being recorded, but I will do it anyways. I think realistically, look, I'll quote Fred Wolsish in saying that there are sort of three corporate venture funds that have proved over time they don't junk up companies. And one of them is getting dissolved right now. We spun out. And then there's Comcast left that's sort of trending. It's very, very hard, I think, for large organizations, strategic corporate venture fund, to be the blocker between executives inside of an organization that can literally fall over and crush startups that they work with. And those startups. So if an entrepreneur comes to us and says, hey, we have the ability to take corporate venture capital or traditional venture capital at the same price, same terms, same everything, like it's sort of a no-brainer, you just take the financial investors' money. I mean, I think everything that, and I probably am not out of line in saying, all three of the organizations represented on the stage outside of Sapphire try to augment or overcome that problem by offering other ancillary services, right? You know that I, for instance, have heard wonderful things about GE's CEO Summit and the exposure that people get to potential kind of customers within the organization. If it were just a check dollar for dollar, you take the financial investors money because they're sort of going to stay out of your operations. But if you take the check dollar for dollar and you get an introduction to a customer, then it's something you have to think about.
Would you agree with that, Grant?
No, I wouldn't. So I think first to say that you're a financial VC when your name actually is derived from the parent company, you're in the same building.
We all have LPs that we need to satisfy.
Yeah. So there's hybrid. I mean, for Google to say they're not strategic, it's kind of a farce. For SAP and Sapphire to say they're distinct is a little bit shaky. So I didn't believe in the corporate model until I actually came over, and I'm of course biased. But you have to just pick what you want out of your investment. If you want to have validation in the market, and for these industrial markets, it matters a ton. It's probably good to have a corporate investor in your syndicate. For someone to provide you a channel brand access, probably good to have a corporate investor. If you're really early stage and you're worried about the monolithic corporation, as Max says, falling over and crushing you, probably best to maybe say, let's get to know each other and talk at the next round. There's a lot of ways that we have kind of solved for that. Start to work with companies and then come in later and cement the relationship with an equity check. But overall, we say no to a lot of companies that our BUs like. We're not going to invest in the company just because the BU comes in and is really jazzed about a company. I actually have a reputation for just saying no over and over and over again, because we have to overcome the hurdle of it being financially viable. At the end of the day, all of the groups have to have the CFO check in at some point and say, are you actually returning capital? You can make up for that with some strategic give back, but you do have the TVPI measure that you have to at some point deliver. So we're trying to balance both things.
So then you're looking at the
I don't know. I didn't think this was a panel of corporate venture.
Well, it's multiple things, right? So go ahead, Mike.
I don't think I'm biased, but I think the answer is it depends on who and what firm you are going to establish a relationship with. Your firm has a relationship, but it's not equal amongst all the people you work with. It has to do with the individual and what that individual's potential to add value is, what their history with their investments is, and their CEOs. And so there's lots of traditional institutional VCs that are on too many boards and have a great reputation, but have a limited ability to add value to the next one. They have an interesting discussion with their LPs. There's different challenges with corporate people, and there's a much wider variety of professional experience with corporate VCs. Although I would say recently, over the last several years, corporate VCs have had the luxury of hiring people who used to be an institutional VC. So it's generally easier to find people who act in a more predictable way and manage those executives in their company from rolling over at the startup. I really think it's individual. It's a myth to say, well, this class of people is better than that class of people. Because the class doesn't matter at all. It's the individual person and their ability to contribute. In my case, you should judge me by my ability to get stuff done inside my company and get my company to come to the table. There's at least one company here whose CEO, thanks for the plug on the CEO Summit, but I could put their CEO at a table and have lunch with Jeff Immelt, the CEO. So it just happened to be the good, right thing to do for that company. So I think it's very situational. I mean, in general, there's bad and busy people on both sides. But I think you really have to do your homework probably more like that yourself. Because the reputation is a little harder to get your arms around until you figure out who to do.
And I would say there's also a trend, especially in the industrial IoT, which I hope we get to at some point, that I see companies taking full rounds full of strategics because it radically accelerates their revenue traction. And I think they have the luxury of doing that. And it's becoming more standard to have VCs at those CVCs who are formulating the financial side. I'm one of those. And I think you're seeing deal terms that look very standard, just like you would get from Anderson or Greylock or somebody. But we actually bring a lot of functional and vertical expertise to the problems that the company is working on. So that is something that we bring. We have 6,000 PhDs inside of our company. That's not something you're going to find in the same way.
Maybe just to plug our model a little bit, what we try to do is bring the strategic value that Grant's talking about, bring some of the right people inside Siemens, give access to customers for the startups, get validation at Siemens, and do it in kind of a safe way without diluting the entrepreneur. And frankly, it's not the capital, of course, in our model that matters really at all. And we work with early stage companies and later stage companies. What really they want from us is the access to our domain knowledge, to our customer base. They want the validation and name of Siemens behind them. And so those are the benefits that we bring. So there are kind of non-dilutive, non-equity related options as well, like ours.
So speaking of domain knowledge, and speaking of the topic of creating digital factories in the industrial space, what domains are you starting to see? Is Siemens really interested in today? And where are you kind of focusing your entrepreneurs, your teams, who you're working with, in the creation of digital factories?
Yeah, so for us, I should clarify too that industrial internet means IoT that spans all of our businesses, at least most of our businesses. I don't want to say every one, but from transportation to smart grid to energy to healthcare to manufacturing, of course, we see applications of IoT everywhere. On the manufacturing side, I mean, manufacturing is really very close to the Siemens heart. Let's put it that way. We're a German company. Manufacturing is one of those things that people take a lot of pride in. We are deeply involved in what's called Industry 4.0, which is the German government's kind of declaration of the IoT initiative. And one of the things I think that separates us from some of the others is that we have, within the manufacturing realm, we have influence in products across both the software side, so what we call kind of the development of the digital twin, which means that everything that has a real implementation has also this digital avatar, so you can effectively predict and follow the progress of anything that's happening in the real world using these very advanced simulation tools. We have that on one side, and we also have this concept called digital thread, which is really the idea that there's a digital interconnection between all devices and that they are connected. So it's following everything from supply chain to production to real-time operations to value-added services and end-of-life of product. There are obviously many use cases. I'm sure we're going to talk about them, like energy efficiency and resource optimization and supply chain optimization, production efficiency, uptime, quality. All these things really matter. I don't want to say that we're focused on any one thing. We're really looking across the board. I mean, we really have interest across the entire span of manufacturing. We are spending a lot of time, to Mike's point, on software. That seems to be kind of the space that we are, it's going to be big. We're gravitating towards it. We like companies that actually have domain expertise in manufacturing. So if you've got some vertical expertise, there are a lot of IoT companies out there. Some are horizontal, some are very domain specific. Well, we like the domain specific ones because a lot of these startups have perspectives that we may not necessarily have. So we're actively seeking those out. But I'm sure as the conversation develops, we'll get into some more discrete areas.
Brent, on the topic of finding domain experts and looking for people in the space, are the entrepreneurs who you work with or tend to work with you, do they have an existing relationship or understanding of the ABB ecosystem already? Have they come from that, or have they come from ABB?
I wish we had more good entrepreneurs coming from ABB.
You have 6,000 PhDs, so I figured maybe a few are like...
We're all very content working on those little problems. And maybe it's just the conservative social culture, man. I'm trying to bring some of the folks I know out here to the Valley and kind of shake things up a little bit, and it's part of my job. But what's interesting is because within Ventures, we're at this nexus of BUs and kind of what they're doing on the periphery of R&D and what's happening in the startup world, we have to have that buy-in. And I've seen so many companies that are generalist IoT companies come in and pitch to ABB and get the BU guys involved, and they're just chewed up and spit out. These are generalists. We're at Analytics Cloud. We were tracking 185 generalist, like generic IoT platforms that were sucking in data and doing analytics on that data and saying that they were going to do predictive maintenance, condition monitoring, and all this stuff. You don't even know what profit it is. You don't know what motors and drives are that we sell. You don't know our business. And they were just spit out. So I think where we've had success are folks that are trying to solve much more granular problems that ladder up to one of our specific businesses. And we've just taken a much more metered approach to that, partially because our team's small, we're only 3 people, and we want to dig into one area at a time. We're starting with more of a hardware bias because that's where ABB, that's our kind of our genesis. Starting with robotics, low power sensing, and some of the specific addressings of pain points such as cybersecurity and standardization, and move from there to some of the broader software applications, more in the areas that GE Ventures is already playing in today. And that's why we've solved these very specific problems within robotics and moved from there. But I would say, yeah, there's a tremendous amount of deep domain expertise in the companies we talk to. See a lot of deep technical backgrounds.
So it's interesting because we probably invest at a different stage as well than most of the folks here. We typically invest through Series B or later in companies. We sort of strictly have to have that mandate or that eye towards a potential IPO. This is a company that could get there, it could be very large, etc. So in and of itself, that creates a threshold. But I would say that one of the things we see, in particular with industrial IoT applications, when you go very deeply, you're satisfying problems that, and actually, I'll step back. How many people walked the factory floor recently? Like a highly automated factory floor? Okay, so it's maybe 10% of the audience. Highly automated factory floors are assembled from hundreds of different component software suppliers, industrial product suppliers, etc. They're stitched together by services organizations that are specialized in these types of things. And to solve problems on an existing factory floor in a very repeatable and extensible fashion often requires this type of very, very particular domain expertise, this understanding of what's going on. For us, the problem when we look at a lot of these businesses, not that they're not good businesses, they're often great businesses, but in order to kind of be a multi-billion-dollar potential outcome, we sort of have to look for that horizontal rethinking of what's there. So we've spent, looking at strictly strictly machine vision opportunity for us is a little bit too small. Because it looks like it's an opportunity to go into something else, somebody else's solution. If it's a more generic deep learning platform, then we can sort of look at it at a more, at a broader base. But I would say that the domain expertise and the ability to go very, very deep and answer a problem today in this area is, it's not like a one size fits all. Like if you're in IoT, that's the way you need to approach it. You just need to understand, are you trying to rethink things kind of at a fundamental platform layer, or are you trying to fix a problem that you can get your hands around today?
So, Grant, you said that, you gave an example, Max, which is, you give an example of deep domain expertise, walking the factory floor, understanding what the specific processes are, and then how Sapphire thinks about investment. Well, Grant has said, well, I've seen 185 basic analytic platforms, very generic analytic platforms, which may have use case specificity to something which my business needs. I don't know what that is, but if it's a generic case, I can't really look at it and investing in it, at least the current status quo. How does it, as an entrepreneur, then actually get domain-specific knowledge if I have something which I think is promising? And is there a way? I think at Siemens there's a way to be connected to the BU. Say, for example, does at ABB is there something similar? Another program which says, hey, you're not ready for to get funded yet, but can you? But perhaps there's another avenue for you to get connected to BU leaders so that you can get that domain specific funding. Because the scenario Max described is actually, obviously. Could be a very high value use case, but you have to have very specific knowledge of the situation.
And I think you're hinting at one of the fundamental problems with the IoT space today is that you're seeing this colliding of the IT and OT world, where you have broader IT platforms that are very horizontal in nature and generally more adept at scaling internet speed with things that are very specific, dealing with specific protocols, security standards, and very entrenched legacy systems in the factory setting. And it's ridiculous how old some of the things are that I see out in the real world. So to try and rip those out, there's a high threshold for value improvement for applications to say you're going to disrupt something that is fairly seamlessly operating in a factory floor and put in some new system, even if it has all sorts of new analytics and reduces your downtime by 5% or something like that. So that's a core issue that we're dealing with. But to your specific question, I think we're trying to be better about that by working with a few groups within ABB. For instance, within our PA group, we have a group that is looking at analytics coming out of a historian products. We have a historian that has much less market share than SAP, but we still are in a good position there on top of our distributed control system product to at least have an in with the customer base that we have. So there's a bunch of companies out there that are looking specifically at the problem of taking data out of historians and trying to do some pre-processing of it, throwing it out into the cloud and come up with insights and doing some predictive maintenance, condition monitoring on that. So what we're doing is trying to deliver data sets to those folks who are trying to come at it from more of a generalist background and see if they can apply more of the IT view of the problem to something that is fairly specific for the factories in which we operate.
Mike, is that kind of a similar view that you have?
So the question is, do I wait for companies that have the right domain expertise, or do I help them get it at some point?
Maybe it's a little bit of both.
Okay. I guess the answer is a little bit of both. Ideally, the trend for us, I'm a software guy, the trend for us is that it started out, there just weren't enough people that had any relevant industry expertise, domain expertise, because of this IT, OT, blood-brain barrier thing. There aren't a lot of old fart people from the OT world who have become successful, then left their company and started a smaller company to solve a problem and receive venture funding. There aren't, the serial entrepreneur thing is very rare amongst the OT technology. It'll happen, but it's still very rare. But we have seen companies that got it enough, at least were relevant enough to us, to where we could then, so I'm switching, so often they don't have enough, they have some that don't have a lot of domain expertise. But what I see happening with some other cases that I see in the audience, and also investments in mine, is that we start to put them in front of various business units with different business problems. And they wind up having 1 or 2 or 5 or 8 different POCs that are generally in completely different industrial use case situations. And in some cases, that's the most important thing we could provide to a startup. It's not money, because if it's a good idea, it's easy to raise the money. But to give you market requirements faster than your domain expertise, in other words, faster than you would otherwise, and maybe avoid a pivot because you didn't make a mistake and made a wrong assumption. So I guess in many cases, certainly after we invest, we wind up putting our companies in situations where they learn a lot about what our customers want through the business units that we're putting them in touch with. It happens quite frequently. It's sort of a hurricane that once they get the updraft, it takes off. But there is this challenge because it's rare for me to meet a person who knows more about some obscure software problem in the aviation business that I can just drop onto one platform. It's starting to happen increasingly now. So I guess the last thing I'll say is because we're building a platform business and we are encouraging people to create what are essentially vertical applications alongside ours for particular industries, it's easier for somebody that has domain expertise in root cause analysis in manufacturing, for instance, to skip the part where they have to know how to connect all the obscure equipment and get to the part where we just give them all the data and they have a lot more fun from then on. So they can take, one company I'm thinking of has already had domain experience in automotive manufacturing and different heavy equipment manufacturing, and demonstrated experience of root cause analysis. And it just made their life easier. I'm sorry, I have to point you out. I really love the t-shirt that says data is the new bacon, because I think I want to buy a lot of those and pass them out at GE Vision. And I think that's the experience that a lot of our companies have is Current, which is a different company, a different domain. Think distributed generation and smart buildings and smart cities. They encourage developers to come to hackathons or create applications themselves by exposing, okay, here's a data set from a city or from a smart building. And here's some generic ideas for applications.
So it's interesting because I think one thing that we haven't mentioned that you hit into that, and I actually am a big fan of a lot of the GE Ventures portfolio when it comes to this type of thing, but I know, for instance, you all have ClearPath Robotics in the portfolio, and ClearPath is experts in LiDAR systems and autonomous driving and rerouting in real time. So there are things that you can, as a technology investor and as potential entrepreneurs and innovators in this space, that you can say are going to be relevant, right? I met with a company, an Israeli company, a couple of weeks ago, and they were networking protocol experts. And they said, hey, I don't need to plug into a PLC to do anomaly detection if I can just like sit on the router system and intercept data in real time. And so they were taking, a very different approach to a problem that had typically been solved in a complex and janky fashion. And those types of things are I think, what we all look for. The deep domain expertise is great, but the other thing that you should think about, like, don't get discouraged if you don't have it, because I think all of us also look for those analogies. Like, how is this going to change, and what can we bet on changing it? Based on somebody who knows something really well.
I think unconsciously, I just wanted to add a comment. Unconsciously, perhaps, we're trying to remove the need to have deep domain experience for the entire stack, right? And hopefully, for some people at least, say, okay, we've if we connect the things and we move the data to someplace more convenient, how about then? Does your domain experience become easier to apply? You don't have to have a sort of 10 people on your staff that know everything about it. I guess time to tell what we're trying to run that experiment.
I think that's the brilliance of the strategy. We put it all into the platform. We can have an app store for microservices. We go after things that completely abstract the data from the underlying hardware that's using all these outdated IEC standards. And that's the world that is increasingly outdated. And I think our product managers get that. And they realize that software is a new world, and it really is the new currency of data and recurring revenue services that's going to take us into the next era of what's a pretty old stodgy hardware focus.
So do you look at your hardware offerings now as recurring revenue offerings versus product?
I wish there was a lot more of that.
Just one comment, Grant, on the speed. I mean, it's interesting because we ultimately have to move at the speed of our customers. And I can say, within Siemens, there's a lot of cultural desire to move faster, to be more disruptive, but the customers are, in many cases, no offense to them, because they're paying their bills, but they are not, in some cases, ready to move on to the latest and greatest. So we do have to kind of modulate our speed to what the customer wants. And in industrial IoT, I think it's going to be slow. I think entrepreneurs should be patient.
It's probably the biggest challenge for entrepreneurs and for traditional investors is that it can be an enormously slow sales cycle, unlike other investment opportunities, which come to fruition a little bit differently.
See, I'm going to throw out a GE Ventures portfolio company. You guys have Rethink Robotics. You're not waiting on your customers. You're investing in a paradigm that will come, and you're trying to be in that space when it arrives. I would say you're remiss if you're betting on trying to innovate at the speed at which the largest incumbents in the world are moving today. The bet is that you need the technology that they'll need in the future.
So on that topic, one trend that's just come out of late from technologies is machine learning. And would love to get your perspectives on, are you investing in, is that a focus area for you right now? And if so, what like intensity, where are the applications that you're seeing? Machine learning, let's say in the near term, like 3 years out or less.
It's a great question. I'm pretty sure most of the companies I'm invested in use machine learning. And we have an active, that's like saying IoT, right? Which IoT, which application of machine learning, which machine learning is sort of like fashion now. So is it deep learning? Whose open source framework are you using? But we see a lot of companies that make very exciting use of all the techniques that have been rapidly evolving and generating quite a lot of revenue. And increasingly, there's a lot of open source software and platform software that those companies can stand on the shoulders of. So it's accessible to a broader range of.
So when we think about areas like robotics or industrial automation, these typical in the digital factory area, industrial internet for UV, where are the near term kind of use cases that you're looking at as high value and saying, this is where I'm placing bets right now? We're skating toward the puck is going to actually skate like the next couple of years.
There's a lot. Can I understand? In every industry that we participate in, and probably all the ones that we will participate in indirectly through our third-party developers, virtually every asset-intensive business can or will be generating an enormous amount of data. Most of it is static and not static, like static on your television. It's like noise. It's not very organized. It's quite different than the kind of data sets that people in ad tech and fintech deal with. But with the right techniques, it's highly monetizable data. And so I think there are a lot of very clever people either supporting the creation of machine learning analytics or productizing them and deploying them inside of something else that provides value to the customer. So the machine learning part is not the important part. It's what's the business outcome for some customer that's better than they can do with people, or faster, or more optimized. So it's really a sort of recurring theme throughout almost, I'd say every investment we do is either directly involved with machine learning or involved in getting data someplace else where machine learning can be applied, or leveraging what machine learning does, operationalizing that, optimizing it, giving a decision to the customer. So it's really, use your imagination. It's really hard to think of one that isn't, an industry that isn't going to be affected.
Debjit, I'll ask you the same question. Are you placing significant bets today from a partnership, technology partnership perspective, or from a venture perspective today in machine learning? If so, what are like some high value use cases that you're seeing you're looking to address?
So yeah, I completely agree with Mike. I mean, they're across the board. We see machine learning in almost every analytics deal that comes our way. It's almost become an integral piece. You almost have to have it. There are probably two driving forces. Number one, we are really looking at a transformation from reactive systems to predictive systems. So it's not just about monitoring and presenting KPIs and dashboards. It's really about knowing where things are going to go, being predictive. So if you think about an operator, think about generic industrial monitoring, for example. It could be in a smart grid control center. It could be on the shop floor. You're overwhelmed with data, right? Connecting more and more devices. These devices are generating lots of information. The problem is you've got people with a lot of domain expertise and experience who are not necessarily used to seeing that data. They may know how to act on subsets of it. But how do you prioritize? I mean, as Mike said, there's a lot of data. It's hard to make sense of all of it. You really have to rely on machine learning now to kind of sort through all of that and extract the patterns that are otherwise almost impossible to detect with this tidal wave, this tsunami of data that's come our way. The second piece is really this idea of the domain expertise. Where does it lie? And the fact is that there are people who've worked in the same place for 20, 30, 40 years who've got kind of the patterns in their head. It's almost like the Matrix. They can see the ones and zeros, and they can make sense of it in ways that other people can't. But the problem is these people are going to retire soon. So we've got this generational workforce issue, this generational turnover, sorry. How do you capture that data? So machine learning, especially supervised machine learning, is a great way to do that. Someone has to make initial sense of what the data mean. So we're very interested in tools that enable us to do that, or enable our customers to do that, so that they can preserve the institutional knowledge that they have and then pass it on to the next generation.
Grant, I'm curious to get your take on something. If we've done, and it seems to me a common trend is that it's very much of a software first type of investment thesis here, where the different, whether you're a venture capitalist or a corporate venture or technology partner, always that. Does that mean that hardware investment, hardware engineering is dead, or is that they're kind of put by the wayside, or is there opportunities for integrated hardware-software combination? What's the role of hardware here, say from when ABB is looking at corporate venture, and if so, can you talk about examples that you invest in?
We're a very storied engineering firm that has a very strong hardware bias. I mean, we like boxes, we sell to utilities, we like smaller boxes, we sell to plants, and we sell a lot of robots. This is all heavy metal. We do sell a lot of software, but it's mostly embedded firmware at this point. So I think you see in our portfolio the things that are very strategic, which are very hardware biased, as I say, they all have software elements. But increasingly we're getting into the software side of things. I mean, the most successful deal at ABB so far has been a software deal. It was an ICS cybersecurity technical industrial defender that was sold in Lockheed. And that was kind of an eye-opening moment that, oh wait, we can layer zeros and ones on top of the stuff we already sell and make it more valuable, more secure, and make a lot more in the process.
So my job was to protect hardware for the most part.
Yeah. So we still sell hardware. So, I mean, that's what we're trying to do is be very selective about where we layer our own intelligence to what we're already selling. So, within robotics, that's a natural thing. Whether it's machine learning, it's all under the auspices of getting more out of your existing resources. With softer commodity prices, aging workforce, higher wages, we have to extract more from our existing assets. You automate, you do more of the data, and at some point in these emerging markets, you're going to see 50% of fabrication tasks be automated, likely by a robot from a company like ABB or Kuka or something else like that. So what we're trying to do is, again, layer of software on top of these hardware assets we're already selling and already have established customer relationships on, and drive intelligence. So one of our investments is Vicarious, which is artificial intelligence to do vision and image recognition in a very sophisticated way. And you'll see more from us in that space. Again, trying to recognize objects for quality assurance or semi-structured manufacturing environments. So these are cobots to quickly down the speed on a new task as we move from station to station, cell to cell. And we're really moving past the old paradigm where you put an ABB robot into a cell and have it do the same task 10 million times with very high precision to a much cheaper, much more mobile robot that will do a task maybe 50 times or 100 times and be on a mobile platform like ClickUp and go do something else. We can be much more adaptable and much more efficient.
Max, I saw you smiling with Ram. Whenever you're smiling, it means there's something going on. So.
Not really. I mean, often I'm stuck in an empty waffle. No. I was smiling and nodding because I think,
We talked about that.
Yeah, we will. I think ABB and I think Grant and I kind of had this conversation a lot. Software is, so if you're a venture capitalist, you love software because software is repeatable, it requires very little marginal cost and to replicate. It's wonderful, it scales. If you can push it through a channel like an ABB or a GE or a Siemens, then all of a sudden you can make a ton of money really fast and like very, very little incremental capital in. That is a venture capitalist dream. But not every problem can be solved with software. And the challenge is that, as Grant mentioned, ABB's out there, software augments a hardware product with the core robots, but ABB has a generation of innovation in the actual hardware asset, and there are certain things that are going to require hardware innovation, and I go back and forth with my partners at Sapphire, because I think when you talk about kind of energy storage in kind of remote, kind of outdoor material movement settings, all of a sudden, there are hardware issues. Frankly, there are chemistry issues that we need to solve, right? And so you asked a question, I think, that's somewhat difficult for venture capitalists to answer because we're trying to maximize returns. The most appealing things for us financially tend to be software and primarily software-enabled products. But I do think there are kind of robotics plays, there's networking plays, anything that's either physically facilitating the movement of electrons is still something that's required when you're talking about automating a smart factory. So there's no way possible that you can take the sort of OT innovation and just say it falls by the wayside. We can't solve all the problems we have with software.
Not to go into complete tangents, but if you actually stipulate all these completely insanely large numbers they're saying about the number of sensors that are going to proliferate all these IoT environments, right there you have a huge issue just with the batteries that are going to power a lot of these disconnected sensors. And if you assume that the useful life of those batteries, just the overhaul of having 50 billion sensors, that's a non-starter right there. So how do you solve that? Energy is a fundamental problem we're going to have to solve to drive into this overall IoT promise that everyone's been harping on for the last last 4 years.
So I was smiling because you asked a loaded question.
Yeah, but we're approaching those really hairy underlying hardware problems as a lead-in to what we're going to do with the software on top. I think there's a lot more maturation that's going to occur with the analytics layer and all the cloud platforms that are developing, but we have to solve, for instance, low-power energy harvesting. And we're looking into innovative ways to kind of look at the micro lab level, energy harvesting chips that the size of our living stick sensors to go inside of the motors. And that will then collect a whole bunch of data, throw it up into the platform, and maybe predicts maybe someone else's, and we can do all sorts of interesting things with that.
Well, as a hardware engineer by training, I'm excited to hear that my training will not have gone to waste. There will be a future for hardware engineers.
It's just not worth this much.
Yeah.
The multiples could be better.
True, true. Before we move on to like a Q&A, I would like the panelists to kind of give their perspective of where you're focusing now. What are the big pain points you are looking to address on behalf of your company? Like the high value, like say 3 high value areas that you're looking to address, and if you could snap your fingers and have a solution for it, you would really unfollow that.
You want me to tell everybody what our problems are?
High value use
Ones they don't already know. How do I use it? Why don't I do this? Why don't I talk about trends that I see that are obviously fraught with opportunity because of this shift. There's a lot of stuff going on the software yet, so bear with me. But there's this shift from, in industrial IoT in particular, from, I call it from the center towards the edge. Right? Foghorn's here in the back of the room, great example of a company monetizing that. But AWS will tell you that, actually it won't even tell you, it'll just assume that you understand you should send all of your data now and for infinity to the cloud, to the center, right? And a long time ago, a number of our customers did the math, and they realized that's going to be really expensive past a certain point that comes up really soon. And gee, that's not going to be fast enough for some of the applications that I need, in case I need to react quickly. And gee, I'm the sovereign government of so-and-so, and I don't trust my data to anybody, to an American corporation. I mean, there's a number of reasons, anyway, where I'm just not comfortable with the cloud. Most of European countries, or companies, are not yet as comfortable as we are, as North Americans, or at least as Americans. The data, something bad won't happen to the data. Anyway, so the shift from the center to the edge is creating a huge opportunity to, for software people to think about writing applications that don't necessarily, you can't assume that your workload will get executed in any one particular place. And then you almost have to assume that for practical purposes, the enormous amount of data that won't be cost effective to ship to the center or fast enough to ship there and get some answer back will probably be at the edge. So how do you deal with, how do you move the workload to the data, more or less, as opposed to how do you move all the data to some central place, just blindly following what's worked the last 5 or 6 years in terms of cloud computing. So that's a long-winded. That's one, center to the edge. The other one is, I'd say from batch to, from relatively slow to fast, from batch to streaming. There's another one of my companies here, Datator. The whole idea about stream processing, which is also a little bit tied up with edge computing, is that there is certainly a lot of opportunities that could be created by processing data after you get it, maybe hours or days or weeks after you get it. But there's also, as anybody who's traded stocks knows, an enormous value associated with reacting very quickly. And so the techniques that we've developed for doing things in batch are being extended thanks to Spark and other platforms, and rethought through thanks to moving some of that processing out into the stream itself as it's coming in. So how do you react faster and maybe break up what is a predictive analytic into parts that get done on the stream as it's coming in, and then other things that happen once you collect it all once it happens. There's a couple more. The industrial cybersecurity is a very important. That's not just one thing, but it's protecting industrial equipment that's on some floor or out at sea or in the air, or your mom is getting a CT scan and you want to make sure that no one tampers with that and irradiates somebody too much. How do you protect the operational integrity of something because the risks are so much higher? You're not going to lose a credit card. There could be much more serious kinetic effect that you want to protect. But so there's protecting this entire food chain, right? Because the attack surface is much larger. It's devices at the edge. It's the data security of the data you collect and you move someplace else and you transform through a lot of kinds of machinery. All of our companies operate on, we have operational data that we, my paycheck comes every couple of weeks, and we close the books on a quarterly basis. How do we know that data is accurate? How do we know that the operational business decisions that we're making are actually based on one source of truth? That hasn't been. Sony found out that that's when your trust in your own operational data fails, then you really sit back. So the issues of data security and IoT security broadly, both at the edge and in the center, is of great interest to us. There's about 3 or 4 more.
So you mentioned the shift in compute power and applications, decisions from center to the edge. You mentioned the shift from batch to streaming, and then the move to pervasive security and integrity of the system.
It's defense in depth applied to industrial IoT. So the people we have to defend against are very talented and have unlimited resources. And so you're never done trying to keep one step ahead of them, or at least making it hard for them to exploit it too quickly.
Debjit, I'd like to think, what trends do you see, or one or two trends that you see of interest in Siemens?
Yeah, so actually they're not that dissimilar to Mike. I think he covered a lot of territory there. I think if you think about it over the long term, this movement towards decentralization is one that we actually face in many of our businesses. One example is smart grid. So it used to be a very centralized model where the energy was flowing in one direction. Today you've got the rise of the prosumer, you've got distributed generation, and all of a sudden the center of focus, the center of business focus is in a different place. This is kind of an analogy for what's going on in IoT as well. The center of focus is going to shift, I think, from the center to the edge. As Mike mentioned, it's going to be more distributed. One of the things that we are focusing on a lot, one of our long-term visions is, if you think about traditional industrial systems, they've been siloed. The greatest value of Internet of Things is going to come when these silos begin to break down. When, for example, a car, which may be autonomous or not, can actually speak to an intelligent traffic intersection, as one example. That type of interaction is brand new, and it's going to require, for example, protocols to be universal. It's going to require a lot of peer-to-peer communication. Making all of that work seamlessly and in a very secure way, security is critically important to us as well, is not going to be easy. Not only do you have a huge attack surface, but if you think about the promise of IoT, the 50 billion devices in the future, you're talking about, for the most part, very resource-constrained devices. So how do you securitize those devices? Not an easy challenge at all. Secondly, you may have kind of a spoke and hub architecture today where everything is centrally connected, but in the future you're going to have vast kind of peer-to-peer connections and distributed intelligence. So tackling all of these problems, how do you make systems work together? How do you make devices communicate with each other and potentially make decisions autonomously, which sounds scary to some of our businesses, but we know it's going to happen. These are some of the things that we worry about over the long term. So we've been looking a lot at cybersecurity, at analytics, at companies that can deploy systems that enable one system to speak to another, so kind of crossing verticals, crossing those traditional silos. Very low cost and very smart sensors, so being able to enable this intelligence at the edge, so to speak. These are all topics that are very important to us. And we've been looking at robotics and AI pretty extensively in the manufacturing space. specifically.
Grant, curious, are you, I think a number of trends were...
Start with that again, Skip.
You're a little last. Sorry, we're trying to talk on a turn. So, are you seeing also, I think one question I had was that with being ABB and the kind of the hub of ecosystems or value chains of your customers or suppliers, are we going to also start seeing the need both for kind of like, they talk about data lakes, so the role of data lakes in automating value chains, the need for software to increasingly automate these value chains in an IoT landscape. Where do you see the trends there?
I think it's a natural inclination when you're trying to solve the digitization conundrum like we are and like many industrial companies are trying to solve is let's take all of our time series data and put it in place, and then we can at least have it in place that we can start to do stuff with. And that is a process that we're going through right now. And I think we're not going to do it nearly fast enough. But the creation of these data lakes, data swamps, whatever you want to call them, is kind of the first step of trying to solve these standards issues, deal with distributed assets, deal with this data federation issue where you have silos in certain companies, certain countries, trying to just get it all into one central repository. So we're in that cloud migration process right now, which is why, for me, in the VC arm, I have to think about the next generation problem, just so I can tee that up, so that ABB has some arrows in its quiver, so to speak, to deal with the next generation problem. And I think you hit the nail on the head. I mean, we're looking at movement from cloud to the edge. It's a natural migration that some of our views are already starting to deal with, because we deal with bandwidth constrained, lossy environments where bandwidth can be very expensive. And I'm working with turbochargers where they're often in the bowels of the ship and they're having to be out at sea for long periods of time and having to batch downloads of all their operating data. And that's something that there needs to be a lot of intelligence at the edge to pre-process the data, and come up with some basic insights for the operators on premise to understand if this thing is operating to spec or not, if it's going to fail tomorrow and need to order a replacement. Same applies to our robotics, where we're in a good position to have these assets that are operating, but we're going to be smarter about not just taking all the data, throwing it to a place and thinking we can then sell services on top of that, and then start to piece down. I think we're trying to figure out how we can create sandboxes to let's containerize the data models for these different assets, allow the customers or the integrators and the distributors that we work with as partners who think they own the asset model, just like we know our motors and we know how they fail. We're not just going to throw that intellectual property up on the predicts and expect GE to benefit from all that knowledge. Not our data. But we want to make it a safe sandbox so that within a given vertical, customer can play with it and start to drive value from it within that specific space.
Thanks.
No, I was going to say that to your first question on kind of where we're making bets and where we see the biggest opportunity or biggest need, developer-focused solutions and builder-maker-focused solutions. This is all of this stuff is too hard to do. And so the more we can invest in things that make this really complicated, SI-driven, just terrible process easier, the more bets we'll make.
I completely, that was like number 5 or 6 on my list, but it's too hard, but the shift to at least the hope that it could become easier is a great interest to us for selfish reasons. And what I was going to say is that this time in history reminds me of, I used to be an investor in the mobile world. So I worked for a mobile operator and I ran the venture fund for Orange in London. And this is before the iPhone, okay, so ancient history. But back then, startups would come and they would play, they were doing valuable things, but they would basically play some wonky role in the plumbing infrastructure of some wireless operator to make things slightly better for that, for a telecom operator, which is a very painful, long, confusing sales cycle if it concludes ever. Then comes along the iPhone, which in my analogy here, it kind of levels the playing field. It opens up a developer platform to a much wider set of people, and it allows people to innovate. There are a lot of mistakes that were made. We know about very successful companies, but there are thousands more that weren't successful. But the rate of innovation picked up. And so what I'm trying to say is that if, and I think we will, when developing an industrial IoT solution becomes easier, I don't think it'll ever be easy enough for one person to create an entire solution. Maybe it still requires teams. But once it becomes easy enough, then the rate of innovation takes off, the rate of experimentation takes off. And if you have 1,000 experiments as opposed to one every couple of years, I think the hit rate becomes more interesting. So we're painfully aware that it's too complicated, and we're terribly interested in anybody that has rapid application development environment. It's sort of the equivalent of what you take for granted now on the web or on a mobile platform when you develop an application. Those, believe it or not, those same kind of quality tools don't exist for most industrial IoT applications.
With that, I'd like to thank our panelists and open up for questions.
Hi, my name is Mark. You kind of just touched on it there for a second, maybe Max, saying about makers and builders. I come from a background of working with industrial systems on like cruise ships. So ABB engineering, a lot of times, I was the person on Crystal Cruises who's like, what if we just take that off of the mainframe, move it onto an emulator, put it on a PC server and see if it works? And everybody just said, you can't do that, it's impossible, this is the way the infrastructure works. So I made a copy of it, loaded it up, the next morning the engineering department comes on and they're like, okay, so our entire cruise ship's running on Microsoft Windows NT. Now we have this maker movement. You were with Orange, you might have come across Luke Eisman, who's now with Y Combinator. You're talking about robots that will be able to take iterations from 5 million to 50. And what applications do you see that are people on the average level that are not currently educated in, SolidWorks or Inventor and stuff, but are actually going to start making parts for robots to design? Or do you see any of that, or are you just worried about smart grids and cars that are going to drive through intersections?
I think we're completely democratizing that whole creation process. My litmus test is always, could I jump in and take one of our new robots? Our Yumi is a 1 kilogram payload, dual-armed robot that I should be able to go in and program it. If it's a simple machine tending task, I should be able to go in and say, you need to open this door, insert aluminum billet, and have it do some stuff. Close the door and do that 20 times before I move to the next cell. If I'm doing that, the simple MBA guy, then I think we're off to the races. And I think in terms of SolidWorks and some of the CAD systems, there's a company that Max and I have talked about in the past called Plethora, but Dogpatch is doing that. Which CAD drop-in.
That's the same people that are talking about advanced manufacturing.
And so it's like streamlining the error identification, streamlining the output of G-code, and our robots interpret a whole different language called Rapid that is completely antiquated. We're trying to smooth all that out because it should be completely invisible to the user what standard you're using, what sort of security is in place, what other standards, so that they just get done what they want to get done.
So it's just a foregone conclusion that those applications will be good.
Yeah, I think right now they need to scale them because right now Plethora is doing very small volumes and go to their shop floor. There's still a lot of manual processes involved in their shop. But you're going to quickly see it where you just press a button and something is sent to you 2 days later that's been CNC milled to your exact spec. I think like 97% accuracy.
I'll do it in 4 hours.
Hi, Suman. I worked extensively with Debjit and his team and building out these IT systems. So one of the things, and I want to get your perspective, is at the outside, if you really look at all these analytical tools that are out there, they use the same set of variations of these machine learning techniques. And even if I want to use deep learning, multimodal, and phase processing, they all get to the same thing. The biggest challenge is how do you actually build the closed loop system that will be useful in the industrial IoT. Coming from the consumer background, I had huge success because we built a lot of A/B testing tools, and I have a way to progressively test and put my systems up there. And in this industrial, especially with the critical infrastructure that you deal with, there are no A/B testing tools there. And to me, that's the biggest barrier to entry for anything that you want to innovate, to put it out there, because I would constantly keep asking them, you know what, it's too risky to put it out there, like, you know, and so you end up building all these software only to, you know, collect this data from somewhere, like, you know, beat any platform and put a nice little dashboards out there and have all this predictive modeling, call this, like, you know, go. I've been involved with IEEE standards, like everything, right? It's just the same, but I haven't seen anything where, like, you know, you really see a true A/B testing platform that I can take all this knowledge and really apply it to the applications or to the physical systems that we need. Yeah? And I would like to get your perspective, you know, what these big companies are doing it and how they are helping out. You know, to me, that's the biggest barrier.
So is the, I just have to ask a clarifying question. Is the question, there's no data set to do A/B testing on for a particular predictive
There's no
model?
system for me to now test my algorithm or, like, you know, my thing to the physical system. You know, we used to do that with flight simulators, but if I were to look at it, you know, I'm working with a KUKA robot arm. Like, you know, now I would like to have a different variations. I'd like to give this, like, you know, train it so that I can understand where I could hold it. Like, you know, it knows the surface intelligence. You know, I don't have that in industry, right? Because I wouldn't be able to do that with.
So on a pure software perspective, I agree with you. I have never met a company worth investing in that is in the software plus hardware space that doesn't devote a meaningful amount of capital to doing just that, which is saying I'm going to continuously run tests and I'm going to kind of experiment with, I will apply I will split test, apply different processes and see what works and what doesn't. And again, this is why not all problems can be fixed with software. But I would say I would sort of counter and just say that great companies that are innovating and kind of with industrial robots, et cetera, are constantly doing just that.
I can't speak for the, because I'm not a robot guy at my shop, I'm the software guy. So I can't speak about that particular use case, but the one I hear about all the time is where are the benchmark data sets? So 6 companies come in and they all say my algorithm's better than their algorithms, right? And nobody can prove that. All they can do is claim they're better. And usually what happens is that in certain controlled circumstances, everybody's better. But in the broad general circumstance, it's all kind of evens out. And nobody's that good. So what we're trying to do is put together, in some cases we have for cybersecurity, we have putting together several collections of benchmark anonymized industrial data sets. So I can stop listening to all these people arguing about their algorithm being the best. We'll have maybe a 15-year head start on what the data says and what it means. And so we have a watermark. And then you get to come in and you get to say, okay, mine's better, and then we'll run lots of tests, or you'll, in a controlled circumstance, get to run your test, and then we'll score it against them.
So, to be fair to the question, cybersecurity is the one place where nobody split tests. You like,
No, that's not true.
you're well, I'd say like in a production environment, you don't say, hey, let me try to reduce costs by under-investing here. You do, I mean, everybody invests for complete protection.
Oh, I guess I'm arguing something different, that we do provide a multi.
Sort of the training data set, but I think what he's asking is for the, how do you build the real world feedback loop into the product itself?
That's right. In spite of all these systems being deterministic, right? You know, these are not like, there's nothing, everything is deterministic and programmed. Like this is how there are boundaries to the IoT, except for security, because they are external to this system. But even in this deterministic situations, I haven't seen a way for my feedback loop working well, because I'm not dealing with this critical infrastructure and I don't have to pay A/B testing, right? So, which is what I was really looking at, like what people call digital twin, like or things like that. Different people call digital twin differently. GE calls it different, Siemens calls it
we call it
different.
digital twin.
Yeah,
Digital twin.
but in a sense, like shouldn't that be like a big focus? Otherwise,
It definitely should be, because for everything we're doing, whether it's modeling robotic movements, mechatronics in the plant floor, or failure modes of our motors, we're having to develop those training sets. So for our robots, because we're moving outside of enclosed cages into open, mostly semi-structured environments, where you might have a hand get in the way, or someone walks in the way, or someone drops an object, or maybe the robot is expecting a door to be open, but it's closed. We have to have ways to model that, figure out what the robot is going to do when it runs into something that it didn't expect to be there. So we're not calling it a digital twin, but at the point cloud, we're creating a virtual space. So the robot knows where in space it actually is and what to do when it comes into an obstacle. This is something that we're trying to solve right now.
But because those environments need to be enriched, like unless you have the robot being in those different settings and you're collecting that data, it's very difficult to be able to build that feedback loop type of
I'm not sure. You want a sandbox that actually has a robot or some reasonable, accurate simulation.
It's not just the robot, even in healthcare or any of why we stick to these old, something that was developed years ago, is because the newer systems are very hard to test, because I don't have the real environment there for testing purposes. That's something I want to get this viewpoint as something that we should be really looking into building that. For robots, yes, there are ways that but really these big applications, because this is this huge argument that we have at SMC as to how does the different computing action, where do you call it success? When it really values, when you see the feedback.
When you sell more stuff.
So maybe just a comment there. I mean, I think you've made actually a great case for why big companies like ours are actually valuable to startups, because in many cases we may have limited test beds. In other cases, we have access to customers. The customers for a startup to go and tell a customer, like you rightly said, to voluntarily bring their machines to a halt or a line or a cell to a halt is very difficult. But with someone like Siemens, they can do that. The other issue is that in the digital factory environment, for example, Siemens has its own factories. So they're not just customer factories, we have our own as well. And I can't talk about it, but it's too early, but a couple of the robotics and machine learning companies that we're dealing with are actually going to probably be alpha and beta tested in our own facilities. So in some cases, we don't even have to open up the door to the customer, we can open up the door to our internal production facilities.
Question here?
I guess can go back to the big picture discussion one more time. Pras Chaudhary, Insight Partners, we are a IoT research analyst group. When I look around in my own research universe, it's beginning to get very apparent that if you look at the IoT value chain, things are commoditizing very, very rapidly. Sensors, gateway hardware, connectivity, data aggregation platforms. There's just too many of them, and it's going to be a price game going forward. There's going to be very little differentiation. That's something that we're beginning to see, with a few exceptions. I'm not saying G Digital predicts it's going to become commoditized tomorrow.
No, I think we're participating in that as well.
Sure. So what really remains at the end of the value delivery chain is really the software, the analytics software. And when you look at the analytics software players today, I mean, the upcoming ones and some of the medium-sized ones, they're still living inside that software licensing model. As in they're more like a horizontal tool delivery player who are not willing to engage into domain-specific problem-solving details. They're leaving it to the client most of the time. So the client is required to license the software, translate the problem into the software and find a way to use machine learning, AI, deep learning, whatever, to solve a real problem and to improve the quality of decision making. And with that mindset, I'm not quite sure how many of these analytics players are going to be able to really create monetizable value beyond their software licensing. I mean, I'm yet to come across a company that says, I'm willing to share my risk with my client, and I'm going to solve the problem for you. If I succeed, you pay me. If I don't, I take the loss.
It's wonderful.
Okay, that's great. So perhaps we should talk later. So, but there's more few and far between.
I think gain share, we call it gain share.
Gain share, yeah, that's the term.
Is for some value chains an increasingly attractive and plausible thing. You may have to be friends with a huge company to survive that, but I think it's, I hear it every fifth conversation around GE these days. So, and there are participants with us who are either willing or unwilling, but we're sweeping them into those situations more.
Well, if they're part of a bigger entity, let's say Siemens floats its own software analytics company. It has its own internal use cases to work on. And you're protected from that market risk of gain sharing by being part of a bigger company. So that's a model that might work. But if you're a standalone software company, just raise your second round funding, you don't want to take that risk.
I don't necessarily think that's true, and that's, if you take, there are obviously gain share models out there. It's somewhat hard to if you're a pure software vendor, it's more hard to enforce. But that's exactly what transactional billing models are for, right? If I create value and you call my API, theoretically you'll only call my API if I am actually providing value. Otherwise, you won't use the product anymore. It's no longer a sort of subscription or license model. So, just sort of say that those models exist, and there are lots of companies doing that.
The other challenge here is, especially in the industrial IT, is oftentimes the monetizable value delivery lies not inside one company, but across the whole entire ecosystem of companies that are working on the same problem. So if it's an automated factory, it's not just the factory itself, but also the freight forwarding companies, the receiving companies, the shipping companies. All those guys need to be instrumented onto the same platform to be able to share a quality of data that can then lend itself to machine learning.
Sounds like a good idea.
Approach. And that becomes a big challenge. The ecosystem play is a big challenge for a mid-sized or small-sized software company focusing or selling its software, analytics software, and IoT.
Right. I certainly agree. I agree with you that it's a challenge to do alone, but we're an example, and there are others of people trying to create enough ecosystem for partners to participate in some value chain in that way. We have, on behalf of, so we can run our own service, but also on third parties, we have an extensive BizOps aspect to the service. So we can meter when your third-party application was called, how much it was used, which API calls were made, just in case that's useful to you, if you're the one having the direct relationship with the customer. Certainly of use to us, because we can feed back to you, hey, there was a spike in your usage after some event, you might be interested in that. Or actually, you have a dashboard so you can see it yourself. But we don't know how it's going to work exactly, but we think that there are lots of different business models, even within gain share, that are possible. But I would say the smaller you are, the less resources you have, the more challenging it is to set up a functional ecosystem and convince somebody to gain share with you or to do value pricing. But I see it's a very attractive model based on some of the large deals that we're creating with different customers, and then people who are either licensees in our infrastructure or third-party application developers on top. It's going to be pretty explicit to them how much they were used in what context.
A question maker.
So my name is Sundar, and I'm the founder of a mobile IoT startup called Wacom. So one of the points that Debjit brought about was that even though there's a long-term value and long-term promise in industrial IoT, right, the short-term customer traction, right, it's a little bit slower than you would expect in a typical enterprise B2B scenario for a lot of reasons. Customers are very traditional, sales cycle are long, and you need this ecosystem play and all that stuff, right? So, but what I find, when a lot of different VCs, especially the financial VCs, I mean, they sort of tend to use the typical enterprise B2B SaaS metrics playbook to sort of evaluate, an industrial IoT startup, right? So, I mean, you need like X million ARR to get funded, Y, right? And that sort of comes from that experience of dealing with all the enterprise B2B startups like Dropbox or what have you, right? So, and do you think some sort of calibration is in order to sort of get to the realities on the ground for an industrial IoT startup? And if so, when and how do you think that calibration will happen?
Somewhat unpopular answer. I don't think there will be. I mean, I think there's going to be a recalibration in the market. I think we're already seeing it on the financial, and I'm sure on the CVC side as well. Prices are coming down, expectations are going up in terms of what is required to receive funding. But the reason that, let me go back to sort of the early 2000s, late 90s. Oracle rolled up the software industry at 5x revenue. Effectively, all of the SaaS metrics that exist are metrics to help you approximate value off of cash flow. The reality is if you're not hitting those metrics as an independent firm, as a startup, and you're getting lower valuation because industrial IoT is longer out in the future, despite the fact that it's a big market, it's a cash flow valuation issue, right? It just because whenever we look at a company that's hardware-based, we try to create an apples-to-apples contribution margin from this hardware product to a software-based business, so we don't kind of unfairly discount it. But we look for those same characteristics. This is a business that can grow in this way, it can achieve an exit of a certain multiple. Because at the end of the day, VCs are just financial investors. I mean, like they're like any other PE kind of entity. And the challenging piece of it is, on average, VC is a terrible industry to be in. Right? Like VCs from 2000 to 2010.
Literally in the top 10.
Yeah, from 2000 to 2010, the industry it lost money relative to the S&P 500. Even if you added back in all of the management fees that people took out, right? It was not a good industry. And so you have the best funds that do fairly well and are very rigorous, making bets and doing well. On average, it's not great, and so you can't really compromise as a financial investor on what you're looking for just because it's a new market.
So here? Yeah. Hi.
Let's take 2 more questions.
Yeah. Hi, I'm Ray Sika, founder of Sensitel. We offer solutions for IoT for transportation. I get the value of IoT at point of use, and we are a big proponent of that. But if you look at the factories itself, like the digital factories, and you guys run quite a number of them. So manufacturing is primarily driven by cost, right? So, I want to design the best product, like Apple, right? And I want to sell it for as much as I can through retailing. But manufacturing is still driven by cost, right? So if you look at Soliandra, right, they had the factory which you could not a worker inside, but they lost out to the low-cost Chinese production. So my question is, I'm not still clear on how IoT gives you that conceptual edge in manufacturing, similar to the waves of innovation in, let's say, the flexible manufacturing or the assembly line which Ford came up with, right? So what are you guys seeing in terms of that conceptual leap which is triggering you to invest into this digital factories, right? And if you can tell me like any one product which you can manufacture, which your competitor can't, or any one factory which you can run at the lowest cost in the world versus, or are you seeing startups which are like Amazon, which will say, look, I'll ship you the product faster than Walmart any day, right? So where is that extreme point of value which is driving you to invest in within the factory, not outside?
We have 435 factories, a lot, like Siemens, and we're about 25% of the way through the first run of upgrading them to be what we call brilliant, which is really mostly bringing them from the 20th century, hopefully not the 19th century, into the 21st century. And the primary motivation is, we call it productivity, but it's cost, right? So there's an enormous benefit to us in our bottom line if we make the same stuff more efficiently. There's all kinds of easy to pick up and fix waste and scheduling, and things get stuck for the strangest reasons. And so, I mean, I'm in some ways not going to give you an answer you like, but it's probably going to remain cost. The easiest one to point to, and there's still a lot of cost to be wrung out, I suppose, is the answer. It's still a lot of low-hanging fruit, so sure, we see other things, but we rationalize most of the investments that are related to employment and manufacturing. Cost sells it. In other words, I can rationalize on cost, and everything else is gravy after that. So if the question is, other than cost, what have I seen that's really exciting? I have to think about that. I mean, I'm sure I usually stop when they say yes, and I don't try and think of more reasons they say yes to me. But it's often some version of cost. It's direct cost removal or efficiency, or push it back into this. It's orchestrating the supply chain so that stuff, we have from time to time $70 billion tied up in our supply chain, waiting to be made into something somewhere else, right? We have way too many vendors, and I think we still have over 100 different ERP systems, and we're consolidating down to a small integer number of them. But we just picked up a lot during acquisitions, and we haven't rationalized that. So there's an enormous amount of cost just lying around that we can pick up there. So we haven't solved all the cost problems and moved on to more exotic stuff after that. I'd have to think about it, because it's a great question, but I don't think we think about what else besides cost is motivating.
I would probably say, it brings in newer business models as well. Like, there are some manufacturing companies that go from selling capital equipment to a service mode, and a lot of innovations there as well.
Okay, but that's a manufacturing and service of a business model.
Yeah, and then there are a lot of companies which
It's not to be low cost, right?
You
You got to make it for less than you rent it for as a service. But yeah, I'm not sure that our manufacturing processes change because we can offer a big hot spinning thing as a service as opposed to a capital asset that you pay for once. That's just at least for us, that innovation happened outside of manufacturing when we figured out, essentially it's an insurance business, right? You figure out the actuarial risk of guaranteeing that this thing you made operates optimally for 10 years and take all the risk. And if you're good at predicting, you keep a lot of money, and if you're bad at predicting, you go broke.
It's a little more like the leasing model in that case. You take capital asset, instead of selling it, you lease it to the customer.
It is leased in some sense, right? So I guess even this is cost, but to close the loop, when we sell something as a service, we realize that the making of the thing and all the data that we generated there, and we tried to be smart about making it and reducing costs, and all the data from how's it operating after we made it, and how to reduce the cost of repairing it and eliminate the cost of unexpectedly finding out the costly repairs necessary. We realized that those two silos weren't talking to each other. So now we're feeding the operation. How's it doing after we made it? And what can we do to make it to design it better and make it more efficiently in the future, continuously, is something that we're doing now. So but even that is, we're trying to reduce the cost of the whole life cycle.
I think let's follow up maybe in questions. Thank you all for joining today, and I want to thank this great panel.